Algebra, Chapter 2, Quadratic Equations, Module 4. In this module, we'll study about the nature of the roots of the quadratic equation and sums based on the roots of the quadratic equation. You know that x is equal to minus b plus minus under root of b squared minus 4ac upon 2a are the roots of the quadratic equation ax squared plus bx plus c equal to 0. If b squared minus 4ac, that is a small term in the formula b squared minus 4ac, if you solve it and you get it equal to 0, then the roots of the quadratic equation will be real and equal. If b squared minus 4ac, if this term, if it is greater than 0, then the roots of the quadratic equation are real and unequal. And lastly, if b squared minus 4ac is less than 0, that means if it is a negative number, then the roots of the quadratic equation are not real. This term b squared minus 4ac, it is called as the discriminant. In this particular sums, we have to determine the nature of the roots of these quadratic equations. So we have to identify whether the roots of these quadratic equations, they are real and equal, real and unequal, or whether they are not real. Let us solve each of these sums. So if you see the first sum, it is the quadratic equation is root 3x squared plus 2 root 3x plus root 3 equal to 0. So in this, if I compare it with the general form of quadratic equation, my a will be root 3, b will be 2 root 3, and c will be root of 3. Now we find out the value of the discriminant, and depending on the discriminant, we will identify the nature of the roots. So we'll find out here b squared minus 4ac. So in this case, b is 2 root 3. So 2 root 3 square minus 4, a that is root 3, and c which is also root 3. So square of 2 root 3 will be, square of 2 will be 4, and square of root 3 will be 3 itself. Minus 4 root 3 into root 3 will give you 3. So this will be 12, 4 into 3, 12, and here again 12. So 12 minus 12, 0. So the discriminant, the value of the discriminant is 0. So the nature of the roots of this first quadratic equation, it will be real and equal. Similarly, if you see the second one, in the second one, the value of a is 1, b is 2, and c is minus 9. Again, find out the value of the discriminant b squared minus 4ac. So in this case, b is 2, so 2 squared minus 4 into a, that is 2, and c, that is b, that is 2, and c, that is minus of 9. So square of 2 will be 4 minus, and this minus and minus will become plus. So this will become 4 into 2 into 9, that is 72. So 4 plus 72 will give you 76, and this is positive or greater than 0. So here you can say that the roots of this quadratic equation will be real and unequal. Similarly, if you see the last one, a is 2, b is minus 5, and c is 7. Find out the value of the discriminant b squared minus 4ac. So this will be minus 5 square minus 4 into a, that is 2, and c, that is 7. So this will be 25 minus 4 into 2, 8, and 7 into 8, 7 8s will give you 56. Now you have to do 25 minus 56. That is minus 31, sign of the greater number, and this is a negative number or less than 0. So you can say here the roots of the quadratic equations are not real. So depending on the value of the discriminant, you can identify that the roots of the quadratic equation, they could be real and equal, real and unequal, or not real. Now let us see the relationship between the roots of the quadratic equation and the coefficient. Alpha and beta, if they are the roots, we denote alpha and beta as the roots of the quadratic equation ax squared plus bx plus c equal to 0. So for any quadratic equation, alpha and beta, will just identify them to be the roots. Then alpha plus beta will be equal to minus b upon a. If you note one thing, b is a coefficient of the x term and a is a coefficient of the x squared term. So alpha plus beta is equal to minus b upon a. This is also called as the sum of roots formula. And alpha into beta will be equal to c upon a, where c is the last constant term and a the coefficient of the x squared term. This is also called as the product of roots. Let us see one example. If alpha and beta are the roots of the quadratic equation 2x squared plus 6x minus 5 equal to 0, then we have to find the value of alpha plus beta and alpha minus beta. So we have the quadratic equation 2x squared plus 6x minus 5 equal to 0. If you compare this with the general form of quadratic equation, my a, that is the coefficient of x squared term, will be 2, b, that is the coefficient of x term, will be 6, and c, the last constant term, will be minus 5. We just studied the formula alpha plus beta is minus b upon a. So this will be as minus 6 upon 2, which will give you minus of 3. Then alpha into beta will be equal to c upon a, and c is minus 5 and a is 2. So your alpha plus beta sum of roots is minus 3, and alpha into beta product of roots is minus 5 upon 2. Next we'll see how to obtain a given quadratic equation having roots. So given any two roots, you can form a quadratic equation by using those two roots. So if alpha and beta, I'll denote alpha and beta are the roots of a given quadratic equation, then I can form the quadratic equation by using this following formula that says x squared minus sum of roots into x plus product of roots equal to 0. So x squared will be the first term minus sum of roots into x will be the second term plus product of roots will be the third term. So we know sum of roots is alpha plus beta and product of roots is alpha into beta. So the quadratic equation will be x squared minus alpha plus beta x plus alpha into beta equal to 0. Let us see an example. We have to obtain the quadratic equation if the roots are minus 3 and minus 5. So here we'll say let alpha be minus 3 and let beta be minus 7. So we'll find out alpha plus beta. Alpha plus beta will be minus 3 minus 7, which will give you minus of 10. And alpha into beta will be minus 3 into minus 7, and we know minus into minus will be plus, and 3 into 7, that is 21. Now if I use the above formula and you just substitute the values, x squared minus alpha plus beta was minus 10, so this will become minus 10x plus alpha into beta was 21 equal to 0. So you can just rearrange this. This will be x squared, this minus and minus will be plus, so this will be x squared plus 10x plus 21 equal to 0. So I have formed a quadratic equation given the two roots. So this quadratic equation will have the roots -3 and -7 if you solve it by any of the method. Now let us solve sums of practice set 2.5. Question 2. Here we have to find the value of the discriminant. If you remember, discriminant is nothing but b square minus 4ac. This value is called as the discriminant. So we have to find the value of the discriminant. So if you see the first one, x square plus 7x minus 1 equal to 0. If you compare this with the general form, a will be 1, b will be 7, and c will be minus 1. So b square minus 4ac, the discriminant, so that will be 7 square minus 4 into a, that is 1, and c, that is minus 1. We just have to solve this. 7 square 49, this minus and minus will be plus, and 4 into 1 will be 4. So 49 plus 4 will be 53. So the value of the discriminant is 53. Similarly, if you see the second one, a is 2, b is minus 5, and c is 10. Do the same thing, b square minus 4ac. So this will be minus 5 square minus 4 into a, that is 2, and c, that is 10. So this will be 25 minus 4 into 2 will be 8, and 8 into 10 will be 80. So this will be 25 minus 80, which is minus 55. Similarly, you can do it for the third part and find the value of the discriminant. Let us see the third sum of this exercise, and here we have to determine the nature of roots of the following quadratic equation. If you remember the nature of roots, we have three types of nature depending on the values of the discriminant. So if the value of the discriminant, that is b square minus 4ac, if it is equal to 0, then I'll say that the nature of my roots of the quadratic equation are real and equal. If the value of the discriminant is greater than 0, then you say that the nature of the roots are real and unequal. And if the value of the discriminant is less than 0, then you say that the nature of the discriminant is not real. So let us solve the sum. So in this, if you see the first one, if I compare it with the general form of quadratic equation and find the values of a, b, and c. So a is 1, b is minus 4, and c is plus 4. Find the value of the discriminant b square minus 4ac. So in this, b is minus 4, so minus 4 square minus 4 into a, that is 1, and c, that is 4. So this will be 4 square 16 minus 4 into 1 4, 4 into 4 16. So 16 minus 16, that is 0. So here you can say that the nature of your roots are real and equal. Similarly, let us do the second one. Find the values of a, b, and c. A is 2, b is minus 7, and c is 2. Find the values of the discriminant b square minus 4ac. So b square, that is square of minus 4 into a, that is 1, and c, that is 4. 16, sorry, this will be 7. So 7 square is 49. So 7 minus of 7 square, that is 49, minus 4 into a, that is 2, and c is also 2. 49 minus 4 into 2, 8, and 8 into 2, 16. So 49 minus 16 will be 33. And you know that 33 is greater than 0. So here my roots will be real and unequal. Let us see the third one. Compare it with the general form of quadratic equation. A will be 1, B will be 2, and C will be 9. Find out b squared minus 4ac, the value of discriminant. So b is 2 squared minus 4 into a, that is 1, and c, that is 9. 2 squared will be 4 minus 4 into 9 will be 36. And 4 minus 36 will be minus of 32, and this is less than 0. So in this case, you can say that the nature of the roots of the quadratic equation are not real. So in this case, you can see there are all three examples. If the discriminant is equal to 0, then the nature of the roots are real and equal. If the discriminant has value greater than 0, that is a positive number, then you can say that the roots are real and unequal. And if the discriminant has a negative value that is less than 0, then you can say that the roots are not real. Let us see question 4 of exercise. Here we have to form the quadratic equation from the roots given below. We know a formula that we learned to form the quadratic equation given two roots, and the formula is x squared minus alpha plus beta into x plus alpha into beta equal to 0. So using this formula, I can form any quadratic equation given two roots. So if you see the first one, alpha is 0 and beta is 4. So if you find out alpha plus beta, that will be 0 plus 4 is 4 itself, and alpha into beta will be 0 into 4, which is 0. Now if we use the above formula, so this will be x squared plus alpha plus beta, that is 4x, and alpha into beta is 0, so it's okay if you do not write it. So the value of the value or the quadratic equation that will be formed by these two roots will be x squared plus 4x equal to 0. Let us try solving the fourth sum. So in this, if you see, I'll take alpha to be 2 minus root of 5, and I'll take beta to be 2 plus root of 5. Find out first alpha plus beta. So that will be 2 minus root of 5 plus 2 plus root of 5. Minus root 5 and plus root 5 will get cancelled, and you will be left with 2 plus 2, that will give you 4. Similarly, find out alpha into beta, that will be 2 minus root of 5 and 2 plus root of 5. Now if you note one thing, this is in the form of a minus b, a plus b. And we know the formula of a minus b, a plus b, then that is a square minus b square. So this will be a square minus b square. Now we just have to solve this. So this will be 4 minus square of root of 5 will be 5 itself, and this will be minus of 1. Now this I can substitute in the given formula, x square minus alpha plus beta, that is 4x, plus alpha into beta, and that is minus 1, equal to 0. So the quadratic equation so formed by using the two roots, by the given two roots, root 5 and 2 plus root 5 is x square minus 4x minus 1 equal to 0. Let us move forward. Question number 6. Alpha and beta are the roots of y square minus 2y minus 7 equal to 0. And we have to find out alpha square plus beta square, and secondly alpha cube plus beta cube. So alpha beta are the roots of this quadratic equation, y square minus 2y minus 7 equal to 0. If we compare this, a will be 1, b will be minus 2 and c will be minus 7. We know alpha plus beta, the formula will be minus b upon a, and in this case it will be minus of minus 2 upon 1. Minus and minus will become plus, and hence you'll get 2. Similarly, alpha into beta is c upon a, which is minus 7 upon 1, which is minus of 7. Now we know the formula alpha square plus beta square is equal to alpha plus beta minus 2 alpha beta. So here we are using the formula alpha plus beta the whole square. We know this formula. This will be alpha square minus 2 alpha beta plus beta square. So this formula, when we rearrange, we get this portion. So we know alpha plus beta is 2. So we substitute here, it will be 2 square minus alpha into beta is minus 7. So that is minus 7. So 2 square is 4 and minus into minus plus. So 2 into 7, 14. So we get 4 into 14, that is 4 plus 14, that is 18. So alpha square plus beta square is equal to 18. Similarly, you know the formula alpha plus beta the whole cube. So this is alpha cube minus 3 alpha square beta minus 3 alpha beta square plus beta cube plus. Now, if we just rearrange this, we'll get this formula here. Now we know the value of alpha plus beta and alpha into beta. Just substitute it. Alpha plus beta is 2, so 2 cube minus 3 into alpha into beta is minus 7, so we'll substitute minus 7. Simplify this and solve it to get the final answer, that is 50. So alpha cube plus beta cube is equal to 50. Practice set 2.5, the seventh sum. The roots of each of the following quadratic equations are real and equal. We have to find the value of k. So in this case, the given quadratic equation 3y square plus ky plus 12 equal to 0. If I compare this with the general form and find the values of a, b and c, a will be 3, b will be minus k and c will be 12. Now if you find a value of the discriminant b square minus 4ac, we'll get minus k square minus 4 into 3 into 12. So this will be k square minus 144. Now in the question it is given that the roots of this quadratic equation are real and equal. So the value of the discriminant should be equal to 0. So you take k square minus 144 equal to 0 and solve it. So if you take 144 on the other side, so if you see at this portion here, I'll have k square equal to 144, and if you take square root on both the sides, you'll get plus minus 12. So k can be plus 12 or minus 12.